Today we are going to talk about the Industrial Communication Protocol OPC UA. But wait, don't leave just because this first sentence sounded kind of boring. I'm very excited about this and I will show you why OPC UA is the best choice for machine tool integrations. As these protocols are abstract and sometimes hard to explain, I've decided to put together a video. We will use two similar devices and we will integrate them into my monitoring system. The catch, of course, one of these devices runs OPC UA and the other one runs the low-level protocol Modbus TCP.
When I call Modbus a low-level protocol, I'm referring to its functionality. Technically, in the OZ model, it sits in the application layer, therefore high level, but in the field, it's about as bare bone as it gets.
Whereas Modbus TCP stands basically for all the other low-level protocols, FANUC FOCAS, Beckhoff ADS, and so on. We will go to the necessary steps for the integration, and this will show you why you should always go for OPC UA, even if you are not a specialist in IT or OT. Without further ado, let's get started. Before we move in the integration itself, let's have a quick look on the setup. We have two Raspberry Pis. The one is called RaspB3 that runs the Modbus interface, and the other one called RaspB4 that runs the OPC UA interface. Both are already connected to my Wi-Fi, so I can access them from my laptop, and my laptop then runs the monitoring solution. On your side, it might look like this. You have multiple machines and you want to connect them to an OE dashboard solution. At the end, it doesn't matter if we're using my setup or your setup. The idea and the process behind it is every time the same. One thing that I would like to mention before we dive into the Modbus integration is how are people connecting their machines today. And I see very often that people rely on the native protocol that comes with the CNC of the machine. And if you have a FANUC machine, then this may be FOCAS. If you have a Beckhoff, then maybe ADS, and so on and so on. The advantage of this is that you don't need to buy additional licenses for connecting your machines. And I understand why this can be a good thing. But if we look at the rest of the integration back here, then you are missing out some important points if you stay with the native protocol. First of all, your OE dashboard solution needs to manage all the different protocols that your machines are talking. This can get quite complex because you need a new connectivity module for each new machine type, CNC type, whatever that you are getting. And the second point is the firewall, something that is not very often talked about, which I find is a very important point, is that if you have multiple different protocols, you really blow up your firewall configuration, because to be secure, you need to manage well which machine is talking over which protocol to what software at the end. If we have a look on how this looks like with OPC UA, then you can see it's much leaner. All the machines are talking the same language. This means your software, at the other hand, only need to talk one language as well. This really reduces the complexity of your firewall and at the end really reduces the integration cost. And why this is the case, I will show you now with my applications. On the Raspberry Pi, there are sitting two different functionalities. The first one is the control of the fan. There are two fans in the housing and we control them based on the CPU temperature. We monitor the temperature of the CPU, and if it crosses a certain threshold, we turn on the fan to cool down the temperature again. And if it crosses the lower threshold, we turn off the fan. On the other side, we have an environmental sensor. We are monitoring the outside temperature, the humidity, and the air quality. As you will see later, all of these data will go into the interface. Let's have a look at the Modbus integration, which we will start with. How do we actually integrate the Raspberry Pi running the Modbus interface? There are two parts to this. The connection, which is already set up. We just have the address of the Raspberry Pi, the port and the IT, and we now need to find out which tags are giving us the temperature, the ambient temperature, the humidity, the gas resistance, the CPU temperature, and the fan status. For this, we need to start with the manual. Our goal now is finding the right registers for connecting the tags to the interface. I've opened the manual on this side and I've opened a little command line tool that helps us read and verify these addresses. We are connected to the same Raspberry Pi. If we scroll up, you can see it's the same host and we are connected. What we can do with this tool is we can read the addresses and get the values. So for example, we can check the general information. We can say, okay, we want to read the address. We start at address 0. We read the next 1, 2, 3 addresses and we get the value. So it seems like the major version is 1, the minor version is 2, and we are up exactly 777 seconds. What do we need first? We need to get the ambient temperature first. So let's have a look. The ambient temperature is register 10 here, BME temperature parameter, and it has a description. Something that is important here is the scaling, and it's scaled by 10, means 25.4 degrees Celsius is actually written as a value 254. Let's verify this. We want to read address 10, and we want to read 1. Okay, this seems to be right. It could be that the room temperature is 23.3 degrees. We assume that this manual is correct. So we can just say we add 10 and as a scale, we multiply it by 10. So we need to scale it back by 10, 0.1. And the unit apparently is degrees Celsius. So we add this. Coming to the humidity, and as you can see, the humidity is apparently 11. So let's read this. 11, 1, and we can see the humidity is 298. We think that this could be correct. So it would be in our case 29.8%. So let's go with this. It's actually 11. Scale is again 0.1, and the unit, what's the unit? It's apparently percentage. Gas resistance, next one. Next one's gas resistance. We're looking here at 12. Let's quickly verify this. It's 12. We have the register. We have one value that we want to read it, and it seems to be 7,003 to 1. It's the gas resistance. Okay, whatever, but it's divided by 10. So in this case, it's 12, 0.1, and the unit is actually not 0.1, it's actually 10, and the unit this time is apparently volts. Next one is the CPU temperature. Where we have the CPU temperature. CPU temperature is now part of the fan CPU control, and we can see it's apparently 30. So for not having to do all of them singly, we will put all of them together. Let's start with 30, and the next 5. Okay, we have 5 values. We have currently current temperature is 47.2 degrees. We have the high threshold is 48 degrees, the lower is 45 degrees. The fan is currently not running, so it's stopped, and there's no manual override going on, so it's following the logic of the CPU temperature. Okay, let's put in the CPU temperature. It's actually 30. Scale is again 0.1, and the unit is degrees Celsius. And the fan status, it's register 34. The scale, we can scale your node, so we just put 1. I hope that's correct. We already have type unit. This is just a little helper from me. I programmed this to make it easier. And the same equation for all of them. What you have seen now is that to be able to connect the Modbus interface, we had to use the manual. We just hoped that the manual is correct. We hope that what is running on our machine was the same that is written in the manual, which is in reality not often the case. The second one is the tool to verify this. As you can see, this is a special tool because I actually could not find any free tool to read Modbus TCP on a Mac. They all were paid versions, so I quickly programmed one for my own, but you can see there are not so many tools available for these protocols. And if we would only read these values and we're not fully sure and they were not fully documented, you can see here these values are just saying nothing. You have no idea if you read only at 30, what is this 47.2? What does this even mean? Is this a temperature? Is this a speed? Is this whatever? You don't know. And also this 0, what does this mean? Does this mean something is running, something is stopped? Is this just a value that is currently 0? Is it even connected? And so on. You are flying completely blind if you're working with a Modbus interface. I think we have now all the informations here. Let's try to run our monitoring app and verify that everything is working as intended. I've opened up the monitoring solution, and on the Modbus TCP side, you can see we are getting in some values. It seems to be more or less correct as the values are scaled correctly. The fan is still stopped and we are getting some values here. On the OPC UA side, as we didn't connect anything, it's still in the connecting state and it cannot connect as it don't has these values, but we will do this next. But I think we can say, okay, we succeeded with the Modbus connection. Now that we've connected successfully the Modbus Raspberry Pi, let's move on with the OPC UA connection. As you can see, we already prepared the connection details. For the OPC UA, we have the URL, and we use a second tool, an OPC UA browser, that we've connected also to this address. You can see this up here in the address line. And directly, you can see that there's a lot of stuff already going on just by connecting to the Raspberry Pi. We see that these two applications, environmental sensor and fan control, is already written here and has something to do with this, and then we have the general information and so on. And if we scroll down to the OPC UA tags, we can see that we need to fill out information for the exactly same tag, which makes sense because it's the same application and we want to connect the same thing again. Okay, let's have a look what we find here. We have these three things that look like that they were relevant to us. So let's have a further look. If we open them up, and if you remember, these are exactly the same tags as we did find in the Modbus manual. You see already the first big difference is that we can directly browse the interface without requiring any manual basically. We just need to know the connection details, and when we've got them, we can use tools like these browsers to better understand the interface itself. Okay, what are we looking at? We have to search for the ambient temperature. And as we discussed before, the temperature is part of the environmental sensor. So we have a look, we have these 4 tags, and here's the temperature. We not only have a display name, we also have a description. If I make this a little bit larger, we can directly see, this is apparently the ambient temperature that we are looking for. It shows us 24.8, but what is it? Let's have a look. We have some more information, and one is the engineering unit, and what you can do on OPC UA, you can specify the units of such values. If we go down here, we find, yeah, indeed, it's degrees Celsius. So we can be sure that the value we got here is in degrees Celsius. This is also true for the others. For the humidity, for example, we have a value 24.4. We can also check the engineering units. We can check the value here, and it tells us it's in percentage. What we are looking for is, as you can see up here in the little example, we are looking for these values, and you can directly see them under node ID as well. So what we are doing to connect these sensors is that we add this like this, NS1. And the same for the humidity. For the humidity we have 10-15, so we do it the same way. And the last one for the environmental sensor is the gas resistance. Gas resistance we got here. We get a higher value, but again, it's exactly the right value that we are looking at. We added the first 3 tags about the sensor. Let's move on to the control. Go to the fan control, and we see all the same tags again, like on the Modbus interface, but we can read them now. We can see, that's the current temperature. So we added this one, and as before, we can find out the units, and the unit tells us, yeah, degrees Celsius. And even it can be in the range 0 to 75, for example. So we take this value and add this one. And lastly, the fan status. It tells us current physical status of the fan, running, stopped. Currently it's false, means it's not running. And there we go, that's it. We already have all the values just by looking at the interface itself. It's not required to have any manual at all. And this makes it very convenient. Let's have a look if we've done everything correctly, and I will start up the monitoring. And here we go. Now we can see values on both sides. We have the Modbus TCP, we have all the values still from the last integration, and we have now the OPC UA values as well. And you've seen, we have not specified the units. These were taken directly from the OPC UA interface, from the software itself. And we are capturing the values, like on the other side, but in a much simpler way than we did before. I can still remember back then when I was responsible for connecting machines to our MES. It was always a hassle finding the right manuals. Sometimes there were no manuals at all. Sometimes the manual was outdated, and sometimes the manual showed a different configuration than our machine. And as you see with the Modbus TCP integration before, it's very hard understanding these values just based on the value itself. It has basically no meaning, and you are really dependent on the manual to understand what tag means what. And this is why I really emphasize on OPC UA. If you have an interface that it explains itself, you don't need any manual at all. You can just connect and explore it and take the data that you need for connecting your machines. This makes it so much more easy, and you can spend much more time integrating and developing new features rather than guessing what means what. And this is why I really emphasize on developing self-explanatory interfaces if you are a machine tool builder, and to use OPC UA if you are integrating machines. And with this, I wish you all a good day and see you next time. Bye bye.